This is Greg with IoT World, and I have the pleasure of speaking with Erik Nordmark. Erik is the co-founder and chief technology officer of ZEDEDA. Welcome, Erik.
Thank you very much. Great being here.
We had a chance to talk at length at the ARC conference earlier this year, so this is kind of a follow-up to the conversation that we had there, Erik. From your perspective, how can traditional industrial organizations balance maintaining their existing OT investments while still adopting modern edge approaches that enable AI and advanced analytics?
Yeah, I don't know how much people have seen about ZEDEDA, but our sort of focus is providing enough sort of infrastructure so that these users, customers, whatever, they can actually have more flexibility when it comes to sort of orchestrating what is actually running out at the edge, right? Whether that edge is inside a factory or a retail location, there could be many different sort of use cases for this. And one of the things that is key is leveraging the agility of this. So the industrial users that are looking more at using the cloud native approaches, right? Building things using modern techniques that are used in the cloud and the data center, and then seeing how can I actually both sort of deploy as well as operate this. And there's a transformation going on there as part of the overall digital transformation where people are doing this. And what sort of is new is saying, okay, how can we do this when we're going to have lots of legacy stuff, right? We're going to have our Windows virtual machines or Windows appliances that are sitting there. Want to be able to turn those into virtual machines so we can actually manage them differently. But also then saying, how do you roll out cloud native, Docker, Kubernetes, whatever? How do you roll out AI? Right? I think the key thing is actually figuring out sort of partners and what sort of substrate are you going to use, what infrastructure you're going to use for all of this stuff. Because I think it makes sense having a sort of common approach to this. And then you can see, okay, for which use cases, which of your business units are you actually going to charge ahead and say, I'm going to deploy hardware with GPUs and leverage this infrastructure for doing that. So you can now actually go out and deploy your inference engines. You can actually go and update your models, etc. And in other cases, you're using that just to say, hey, how do I update my sort of bread and butter 10 or 20-year-old Windows running as a virtual machine on this thing? And now it becomes use case dependent, right? But the whole sort of workflows and the way you operate this stuff, the underlying security and integrity mechanisms are actually the same. So, but it is going to be an issue because it is also sort of like, how do these industrial companies operate internally? How do they develop this software? How do they test it, right? How often will they update it? So in some of these areas, it's a very different, life cycle, not only in terms of how they operate, but also the timing of it. So, but I think that having this sort of key partner and underlying infrastructure for this stuff makes this stuff feasible, but there's still other things that they need to do.
Yeah, I know you've talked to a lot of organizations and worked with a lot of organizations from a pretty broad spectrum of different industries and applications. What misconceptions do you see industrial organizations having about securing their connected operations, and what approaches should they prioritize instead, possibly?
So I mean, I think that it's actually, I feel that it's accelerating in terms of the things that people need to be concerned about, because there's things like the EU Cyber Resiliency Act, there's CISA in the United States that have been arguing for things like, secure by design approaches and sort of NIST in the US as well, sort of like, and some of these things actually are more carrot, some of them are more sticks, sort of penalties and whatever type things. But I feel that this is a challenge because I feel that the concerns here are accelerating, but also the sort of approaches are accelerating. So, and how deep into the different organizations do you need to bring this level of security awareness? Well, it depends what it is, right? Certain things that are supposed to be known, like, okay, let's use standard things like TLS for, encrypting things on the wire, but also sort of like, don't put default passwords in your product, right? There's a certain set of things that they need to diffuse through their software development organization in terms of how they do this. And this might affect other things as well. Like, okay, if your technicians are used to there being a default password when they show up, okay, it's not going to be that way anymore, right? You need to have some other mechanism. That's one thing. But I think that you know, and in some cases, it's easier because they can actually depend on the underlying infrastructure, wherever they're getting it from, for some of these security pieces. I think that they need to chase, so to raise awareness internally, right, is a key thing, and then see what parts do their own software developers have to worry about? What parts do they need to see? Okay, what am I getting from the operating system? What am I getting from the network partners I have? The orchestration partners, etc. So it is sort of trying to map this stuff out. But I think one of the key things across the board is looking carefully at this. What does secure by design actually mean, right? The other thing that I think is a bit subtle and it's useful for people to understand this across the board, even sort of up to the C-suite, is that security is one thing and compliance is a different thing. And in some cases, they're actually at odds with each other. This was pointed out to me after the OpenSSL Heartbleed bug, right? That there were things that were certified from a cryptographic perspective against FIPS 140. And then there was a bug. So now you had a choice saying either you're running the thing with a bug fix in OpenSSL, or you're waiting for that bug fix to be certified, which takes 12 months. Right? So sort of like and in some cases, people might focus more on the certification thing. It's actually important from a legal perspective, but you also have to think about, okay, is the actual solution both sort of secure as well as do I know how to operate this stuff? Or do I get into this thing saying, hey, my technicians don't know how to service things anymore because we don't have that, whether it's the default password or something else. We're changing the way we're interacting with things so that all of our processes sort of get a lot more complex, right? So sort of like, I think key is finding, and part of this, is something that we've been striving to do, is making this securing the system actually be so easy that you don't have to change your processes, right? You still have to worry about how your application is secured, etc. But you don't have to say, hey, it's a completely different universe. The developers do it securely in their lab. Now, somewhere as part of this becoming deployed in production, we turn on security and suddenly everything gets 10 times harder to deal with, right? So you want to avoid that. You want to think of it, run it securely from day one, right? So, yeah.
Indeed. I mean, are you seeing, kind of to your point on the regulatory piece and certification, you're certifying against a standard, right? Or a series of standards. What's your perspective on the evolution of that? Is it keeping up? Are we behind in the standardization side? What's your perspective there, Erik?
So, I've deep dived into some pieces here that's around sort of integrity protecting the platform, and what does that mean when these things are sort of distributed potentially in non-physically secure locations, right? And I've sort of observed that many of the things that we use as sort of state of the art today is things that were designed for your desktop, your laptop, your smartphone, where it's actually a user in front of that. So if something goes wrong, you can tie back to, okay, what's the fingerprint reader, the PIN, the password, whatever type thing, right? And that's a model that works very well in that domain. But this is, to the extent that this is sort of industrial IoT and edge computing, it's attended edge computing, right? Attended devices. And many of these cases, you want to say, no, but these are devices that are sitting out in the plant, in the production line, or out at the solar farm, whatever it is. And they need to function even if there's no human being there, and deal with sort of like the power went out, it came back, and there's no one there. If something, quote unquote, goes wrong, it needs to be autonomous, but it needs to be autonomous, or it needs to be enough automatic that it can come back up, right? Maybe autonomous is too strong, but it needs to do that in a secure way, right? And that, the sort of notion that what are the techniques that you can do this at scale, the sort of what you find that if you go read and ask consultants, and they might point you at, oh, here's the state of the art, but it's actually for the attended part, not the unattended. So I've seen people that have published this, like, how does Google run internally around their cloud? I think they're the only ones when I've heard them actually publishing how they do this stuff, which is a different set of techniques, which is actually relying on attestation and having, basically doing checks by a third party, right, inside the cloud. And this is basically what we have built for in ZEDEDA with EVOS and in the open source, saying, okay, we're doing the same thing at the edge, because this actually now enables us to have a third party. And that means it can actually work even when this is unattended, because if something changed, it will call for help on the network. And there's an authoritative entity there that says, you either pass the attestation check or not, meaning that you're running the BIOS, the software you expect, right? But it is a different way. And at a high level, sort of like, don't make sure you're not looking at sort of the current solutions or yesterday's solutions for a different problem in this domain when it comes to certifying, and it applies to standards as well as sort of the organizations building this stuff, certifying against what is the norm for the attended devices. And I think that this is an area where we need to figure out how to evolve these standards to make sure that we can sort of not lock down into something that's suboptimal for the unattended side. But instead looking at how can we use the tool set, because the tools are there. There's lots of organizations build lots of great security tools, open source, standards, whatever. But it's more about figuring out, what should the actual requirement be for this space.
Yeah, and you're touching on kind of my next question too. As industrial systems become more and more software defined, what organizational and workforce changes do you see as key or most critical for companies that are transforming from that hardware-centric model to more of a software-enabled operators?
I mean, I think that you're going to have more software developers, and sort of like delivering the value by having the software. It means that from a business perspective, you now can actually move faster in terms of improving things, upselling other things, right? If you have the right partner and infrastructure, you can sell new functionality without having to physically go visit. It's just another software download, but it needs to be trusted, etc. Right? But it means that the way you think about testing might be different, because you're deploying this hardware. The hardware might still be out there for 5, 7, 10 years running in the plant. Okay, how do I actually know that I can test this as I roll out new software over time, right? The customer relationship in terms of expectations, I think that changes as well. Part of this is because of the inherent need that once you go and connect up things to the internet, you have to be more worried about security attacks, which means you need to at least be able to drive out security patches, right? Well, it means that you will have some changes. You can't just say, no, I built this production line, I'm not touching it, right? For the next 10 years, right? Nobody changes anything, right? No, that doesn't work.
Not
right?
the world's I've lived in.
Yeah. But then what does that mean? Does it mean I'm also allowed to roll out new functionality, right? And what part of this is, what should I develop as an organization? How can I roll out these things without actually requiring the customer to install a new box, a new hardware industrial PC that runs the new functionality? Just a software addition to what you already have, right? So the software developers is one thing here. The other thing is, how do you think about what you're selling to your customer? If you're selling into industrial companies that are used to, they're buying, mechanical devices, electromechanical devices, okay, they have microcontrollers inside. But anytime in the past when they bought things, it's been a physical object, right? Well, are you still viewing this as you're selling them a physical object that happens to have more software inside? Well, but you want to upsell the additional software-driven improvements to that. But how do you actually evolve this sort of customer conversations, right? But in some cases, you say, well, if you go in there to the existing customers that are used to more buying the physical artifacts, and say, hey, we have a software as a service solution, they don't know what you're talking about, right? It's not something that they're used to buying from you, right? So I think that's something where you have to be careful, because it's not only the suppliers in this picture that needs to change. Their customers need to see the benefits of this and sort of understand the journey that we're collectively on in terms of more and more things being software defined, more and more flexibility, more and more sort of change rate at some level, but managing the safety and security and sort of operational aspects of those changes is actually key, right? But I think that this will, in some parts of this domains, this will actually accelerate. I mean, people have been looking at virtual PLCs and how can I get things like this safety certified, which is a completely different set of concerns, right? How are we moving rapidly in that direction? Where okay, we need to get a lot better at doing software, right? Building the systems, validating them so that we can actually not just get the certification, but really saying, okay, we believe that this is actually dependable enough, right? It's not just getting the stamp of approval. It's really that I know that this is not going to break because I changed something over here and it's going to break over there, right?
Tell me if you can, you take out your crystal ball a little bit, and what excites you the most about the path that we're on right now, and looking at all the the artificial intelligence aspects and the next generations, connectivity, all of that. What excites you the most, and then maybe the flip side of that, what scares you a little bit or keeps you up at night, if there's anything?
Well, I mean, I think that, and I told my wife, I found this during my career, it's sort of like building something. I mean, I've been a technologist all along, sort of building something, but then seeing how does somebody who wants to use this take it and fit it into their environment. And as part of that, sort of learning together that, wait, you have a completely different set of constraints than what I thought when I was sitting building this stuff, right? And sort of realizing how can we together move this forward, because there is so many sort of pieces, so many things you could actually do here, but you need to connect these things, right? I mean, people might talk about the sort of OT, IT, and how do they work together? Well, but it's actually deeper than that. It's actually, if you back up, we have all of this IT components, technologies coming in, right? Hardware, software, etc., right? And sort of getting that out where it's actually useful, right? People have to understand a bit more about what is actually the intended use of this. What are the constraints, the requirements out in that thing, whether they're safety ones, whether they're operational requirements, how do people actually work? What are the different roles? Who approves what, right? There's lots of things in the overall bigger pipeline. And what excites me the most is actually making sure that stuff actually glues together, actually learning from other people that are experts in their domain, and then saying, okay, what does that mean in terms of what you need to build more in terms of the software infrastructure, the solutions that go into this stuff. I mean, and there's lots of technology there. You still have to realize that, yeah, getting this technology, sort of like the hype cycle, right? Yeah, there's things that can be exciting, that could be very deep, sort of, let's go do this now because we have a very specific use case. But it's also seeing how does that longer, sort of slower deployment when this stuff becomes more mainstream, right? What will that actually look like? And all of these sort of like different people jumping on things and trying to understand things for different domains. AI is a great example. People are building high-end, low-end GPUs that's accelerating from a hardware perspective. People are also looking at, hey, can I approximate this model so they can run on a CPU so I don't have to replace that GPU hardware every 2 years and completely mess up my hardware replacement cycle in the plant, right? But if the software guys can figure out how to run it on the CPU efficiently, right? Approximated models, etc., right? SLMs, not LLMs, etc., right? There's all of this stuff going on that is very interesting, because now we can say we can still live within the sort of existing operational constraints of saying you deploy this stuff. Yes, the software will get better, but it's a lot easier to update that than saying you need to get a new GPU every 12 or 18 months, right? And change your hardware.
Yeah.
So they're sort of like accelerating things, but still keeping it grounded into what's the actual reality out there.
No, that's great. I appreciate the insights. Thanks so much for sharing with us today.